So lastly today, we are going to talk about converting between units of pressure in the context of measuring pressure. And we're going to talk about the measurement of pressure using a closed-end manometer. So remember, a manometer, manometer, even though it looks like a unit of measurement, like a nanometer, a manometer is more like a barometer. It's a device for measuring pressure. And specifically, a manometer is used to measure the pressure of a trapped sample of a gas. So our manometer is shown in this picture here. We have a sample vial of gas with a stopcock that we can open up so that the gas in the sample vial can exert pressure on a column of mercury. And when the vial is opened up, the gas escapes, pushing back on the mercury reservoir on this end and raising the height of the mercury equivalent to the pressure of the gas. So that's the key thing to keep in mind in a manometer. The height that the mercury is raised when you open the gas chamber is going to be equivalent to the pressure that the gas can exert. So originally, before the gas sample was open, the mercury reservoir height was here. When the stopcock is open and gas is allowed to flow into the system, that actually raises the height of the mercury reservoir from here to here, increasing the height of the mercury by 26.4 centimeters. So the key thing about the manometer is that the gas in the vial has a pressure equivalent to 26.4 centimeters of mercury, and we would like to convert that into torr, Pascal, and bar. So remember your relationships. Torr and millimeters of mercury are equivalent. For pascals, we have 101,325 pascals per atmosphere, which is equivalent to 760 millimeters of mercury. And 1 bar is equivalent to 1 atmosphere, or 1 bar equals 760 millimeters of mercury. So again, this is really straight dimensional analysis. The key thing to recognize is that if your manometer's mercury height raises 26.4 centimeters, that's going to be the pressure of the gas trapped in the sample holder here. So the key thing to keep in mind is that the pressure of the trapped gas raises the height of the mercury column by 26.4 centimeters. Therefore, the pressure of the gas is equivalent to 26.4 centimeters of mercury. And we can use dimensional analysis to convert that to torr. 26.4 centimeters of mercury, we have 10 millimeters of mercury per centimeter. And we have 1 torr per millimeter of mercury. Therefore, the pressure of the gas is equivalent to 264 torr, to 3 sig figs. We do the same process for pascals and bars. Well, we can start where we left off with 264 millimeters of mercury, or 264 torr. There's 1 atmosphere per 760 torr, and there's 101,325 pascals per atmosphere of pressure. So we take 264 divided by 760 times 101,325 pascals. Torr cancels with torr, atmospheres cancels with atmospheres, and the pressure the gas is exerting is equivalent to 35,197 pascals. And again, ultimately, when we report our answer, we're going to shrink this down to 3 sig figs. So 35,200 pascals. 35,200 pascals times 1 bar per 100,000 pascals will give us our pressure in bar, and 35,200 divided by 100,000 would give us a pressure of 0.352 bar. Pascals cancels with pascals. Reconciling our sig figs, and remember that we're only entitled to 3 sig figs in our answer. The equivalent pressure is 264 torr, 35,200 pascals, or 0.352